Alright guys, question. Write the sequence 4, 7, 12, 19, 28 as follows. Get the first difference. First difference is 3. Second difference is, the first difference between 7 and 12 is 5. The one after that is 7. The one after that is 9. We can see that it's a 3, 5, 7, 9, 11, 13. That's the differences each time. Second difference is the gap between 3 and 5, which is 2. 5 and 7, which is also 2, and 7 and 9, which is also 2. If Tn equals An squared plus Bn plus C, use the second difference to write down the value of A. The value of A is a half of the second difference. A half times 2, A equals 1. How many people got that far? Okay, grand. Next part. Hence find an expression for Tn. Tn now equals n squared plus Bn plus C. This because A equals 1. Use T1 equals 4 and T2 equals 7 to find out what the rest of them are. So for example, T1 equals 4 means n is replaced with 1. N changes to 1. Change all other n's to 1. 1 squared plus b times 1 plus c all equals 4. 1 plus b plus c equals 4. Bring over to 1. b plus c equals 3. Okay? That's T1. T2 is 2 squared plus b times 2 plus c, and all of this equals 7. 4 plus 2b plus c equals 7. Bring over to 4. And what we get here is 2b plus c equals 7 minus 4, which is 3. How many people got the two equations out? Okay, so we're working off smaller numbers now. Okay guys, next thing, you have two equations. You need to do a simultaneous equation on them. Now, currently, if you add both of them together directly downwards, okay, what would happen is you'd get 3b plus 2c equals 6. That is wrong. You don't want that to happen. What you'd like to happen is you'd like them to cancel each other, or one of the letters to cancel each other. So what we need to do here is we need to change the signs on one of them. Let's change this one here, so let's multiply across by minus. So it's minus b minus c minus 3. The reason you're allowed to do that is if I told you that 4 plus 2 equals 6, if I changed the signs on both sides and I said minus 4 minus 2 equals minus 6, you notice that the equation is still balanced once you do the same to both sides. Now you can add directly downwards, and what you should get is b plus 0 equals 0. You should get b equals 0. Okay? Now, because we know b equals 0, we can go back to the top, replace b with 0. 0 plus c equals 3. What does c have to be equal to? C is equal to 3. And we know a equals 1. Therefore, Tn equals an squared plus bn plus c. Therefore, it's equal to n squared plus 0 times n. Anybody? 0. 0 times n is 0, and c is 3. Tn equals n squared plus 3. Okay. Can anybody tell me how you check that? 4, 7, 12. How would you check the answer? No, you can check it yourself in a test if you want. T1 is meant to be 4, isn't it? Yeah? Replace all n's with 1, and what you get? 1 squared plus 3 is 4. This was me checking my answer. What's T2 meant to be? T2 is 2 squared plus 3, which is 7. Does our equation work? Yes, it does. This is the correct answer. Okay? So this is the correct answer. Okay, number 8. Show that the terms of quadratic sequence 8, 15, 26, 41, 60 is given by this formula here. Okay, do what we always do. Prove it. Okay, 8, 15, 26, 41, and 60. What's the first difference? Sorry? 7, 11. Is that right? 7, 11, 15, is it? So just give me a sec here. 7, 11, 15, and 19. And each one of these is the second difference then. What do we get? Sorry?
You have to do this.
Yeah. That's 4, 4, and 4. Did you just plug in numbers, James? Say T1 gives you that, T2 gives you that.
Yeah.
Yeah, but you should prove it from scratch though. I thought about doing that myself, but I'll just keep the same technique. Okay guys, what's our A value?
2.
Okay, A equals a half of the second difference. It's a half for A equals 2. The 2 is proved. We next have to prove that B equals 1. And after that we have to prove that C equals 5. Okay, so let's go about doing this. Okay guys, Tn now becomes n squared plus bn plus c. Let's use T1. T1 equals, what do I do with the ends? What do I do with the ends? 1 squared plus b times 1 plus c, that all equals 8. That 1 squared is 1. Bring over the 1, it becomes a minus 1. B plus C equals 7. Okay? We know that B is 2, B is 1, C is 5. So B plus C should equal 6. Just give me a look at this here. Yeah.
It's not 2n squared.
Oh, it is 2n squared, you're right. And that would rectify my answer, wouldn't it? So it's good to check as you go along. So this is actually 2, and this is minus 2, which turns this into 6. Now, as it turns out, B plus C is 5 plus 1. Is 5 plus 1 6? So you can see in that question we could check as we went along. I knew there was a mistake, you knew there was a mistake, and we were onto it, weren't we? We knew to check it before we moved on. Next one, T2. 2 times 2 squared, so replace all ends with 2, plus b times 2, plus c equals, that is going to be, what's the second term of the sequence, guys? 15. It's 15. So what does this become here? 2 times 2 squared is 8. Bringing the 8 over the other side, and it becomes a minus 8. Now what we're going to get is 2b plus c equals 7. Do we have our simultaneous equation made? 1 and 2. Let's do these out. 2b plus c equals 6, or sorry, equals 7. What do we need to do with this equation here? Change it to minus. Minus b minus c equals minus 6. Cross it over. And we're going to get b equals 7 minus 6. B equals 1, as predicted. We now know that b plus c equals 6. If b is the number 1, what does that tell you about c? C is 5. Is that what we're asked to prove? B is 1 and C is 5.